everyone. Today we're gonna learn section 3.4 motion in space. So we have a learning objective here. So in the calculus one, how do you find the velocity and acceleration and speed? So if we have s of t position function, so we can use any letter, right? Any variable. So we are using just s of t, which is position function. Then how do you find velocity? Then we do derivative of the position function. Then we denote first letter v from the velocity. So v of t, which is the derivative of position function, right? How about acceleration? So we are using first letter from the acceleration and a over t. Then we make the second derivative of position function. That is first derivative of velocity, right? What about the speed? Speed is absolute value of the velocity, right? How about calculus 3? How do you indicate the velocity, acceleration, speed? So calculus 3, we are using vector valued function, right? So this is actually in calculus 3, we called just a real valued function, right? In calculus 3, right? So we have vector valued function. So we learned the last time how to derivative, how to integrate, right? So we say that velocity vector so same. So we are using first letter v of t, but it's a vector notation, right? So v of the first letter v, so v of t equal to r prime of t, right? Same as calculus 1. How about acceleration? It's the same. We follow same concept. So acceleration. So using first letter A, so it will be vector notation with A over t equal to V prime over t. That is the same as R second prime over t, right? Okay, let me change this one a little bit. This one looks like a double prime. Yeah. What about the speed? Speed. We had absolute value of v over t. So in the vector, how to make speed absolute value. So we're not using absolute value. We are using magnitude, right? I think we did it before, right? So speed, magnitude of vector v over t. That is the same as magnitude of r prime over t, right? So here's missing s prime over t there. Yeah, make sense? So basically we're following same concept with the calculus 1, but calculus 1 we had a real number, right? Real function. Calculus 3 we have a vector function. So exactly the same, right? Okay, let's do this problem. Okay, so here is the example. A particle moves in a parabolic path defined by a vector valued function r over t equal to t square I plus square root of 5 minus t squared j, where t measure time in seconds. Okay, we're gonna find the velocity, acceleration, and speed. So velocity, we had all the formula here, right? So let's bring down. Okay. Okay, velocity, which is the same as first derivative of the vector valued function r over t, right? So we do derivative, then there will be 2t I had, and that will be, this will be 5 minus t squared, 1/2. Yeah. So then we drop the power, reduce by 1, negative 1/2, and chain rule inside. So that is negative 2t j here, right? Okay, let's simplify. So 2. So that will be 2t I had minus t, 5 minus t squared, negative 1/2 j had, right? Okay. Okay, more rewrite. So that will be 2t I had minus t over 5 minus t squared, 1/2. Because we want to find acceleration in the next. Okay, so this is the one. All right, so acceleration, let's find out. So we denote a over t, which is first derivative of velocity, which is the same as second derivative of the vector valued function. Okay, so we have 2ti. So what's the derivative? 2. Yep. I. And how about second term? J. Here. So we are using quotient rule. So we have f over g derivative, then f prime g minus f g prime over g squared, right? Okay, so f prime, it will be messy. Let's give it to negative to the numerator. So plus then f prime, which is negative 1, g 5 minus t squared, 1/2 minus f negative t g prime, so 1/2, 5 minus t squared, negative 1/2, and chain rule negative 2t, right? All over g squared, which is 5 minus t squared, 1/2 squared, right? And then j term, j hat. Okay, so let's make a bracket. Let's just simplify. Simplify. All right, so let's see. 2 again, right? And then 2 over 2, right? That's it. So we will have 2I hat plus negative, right? So negative 5 minus t squared, 1/2. And we have negative t, which is positive t squared. Well, we have a negative, right? So negative t squared and 5 minus t squared. How about the make a denominator, right? Because negative 1/2. So I am talking about this, yeah? So that will be over 5 minus t squared, 1/2, or over 5 minus t squared, right? Okay. So let's make a common denominator. So that will be over 5 minus t squared, 1/2, and times, no space, 5 minus t squared, 1/2. Yeah. Okay. So that will be 2I hat and that will be let's see, well, so we keep the negative, right? There is negative. Oh, keep doing that. Come on. So we have negative. So we keep that negative. Okay. So we have same base. Then multiplication. We add their power, right? So let me write down here for you. Note 5 minus t squared, 1/2. Five minus t squared, because 1/2 plus 1/2, that's 2 over 2, right? So okay. And we have, can you do that? How about this? Let me write down for you. How about that? So clearly, yeah. But then we have a negative, right? So I want to distribute the negative. So 5 plus t squared. Okay. Then minus t squared. And then the denominator is 5 minus t squared, 1/2, all over, sorry, a little bit messy, 5 minus t squared there, j hat, right? Okay, so we have two fractions there, so let's simplify. So 2I hat plus negative 5, right? And we have 5 minus t squared 1/2 times reciprocal of second fraction. So it's 1 over 5 minus t squared j times. So 2I have plus, it's multiplication, so we have -5, right? And then 1/2 times 2 over 2, so 3 over 2, right? So that will be 5 minus t squared, 3 over 2 j hat. Or we can write down -5 here. Is okay? How about speed? So speed is magnitude of the velocity vector, which is the same as the magnitude of r second prime of, right? Okay, so let us print r prime of t. No, basically we have, oh, I made a mistake, huh? R prime of t, not the r second prime, yeah. So we have r prime of t if I make a mistake, please tell me. I know no one is here. Okay. All right. So we have the, let me write out. So we have a v over t, which is same as r prime over t. Okay. All right. So magnitude v over t, which is the same as magnitude of r prime over t. That is the square root 2t squared plus -t over 5 minus t squared 1/2. Square them. Yeah. Okay. So that will be square root 4t squared plus t squared. Distribute the power. So we have 5 minus t. Let's make a common denominator. So that will be 5 minus t. So 5 minus t, 5 minus t. So we get 20t squared minus 4t to the second power and plus the t squared, right? Okay. Oh, everything t to the third power. Let me see. I made a mistake, huh? Ah, t squared. Yes. Sorry about that. Keep making the mistake. So t squared, right? Sorry about that. I did not make a mistake up there. Okay, then 20t squared, 4t to the fourth power. Yeah, okay. Then combine like terms, so we will have denominator has 5 minus t squared. And then numerator, negative 4t to the fourth power. And 20 plus 1, 21t squared, right? One t squared. So we cannot do anything. So we just leave it like this. All right. Let's do second part. They don't say anything, right? So what is the t equal to 1? Yeah. They just say that find the velocity, acceleration, speed as a function of time. So they don't indicate what time, right? Yeah. Okay, so let us do second part to sketch the curve along with a velocity vector at time t equal to 1. So let's do it when time equal to 1. All right, so um, let's draw the vector function first. So we have r over t. Where is it? Yeah. So let's find out this vector function first. So r over 0, we get 0 squared, which is 0, plus we have 5 minus 0, j, right? So that will be square root of 5 is j, right? So this one approximate 2.24. Okay, how about 1, right? So 1, we have 1 square, which is 1. So I had plus 5 minus 1 squared, j hat. So that would be I hat square root of 4, which is 2 j hat, right? Okay, how about r over 2? So we have 2 squared, I hat, plus square root of 5 minus 2 squared, j hat. That will be 4 I hat plus j hat. Yeah. Okay. Now we cannot have a 3 because we substitute the 3 here. It's 9. Then we don't get the real number, right? So we don't want square root of 3. But let's take a look. One number we make a square down, we get 0 at this part, right? So that is the square root of 5. Let's try square root of 5. Then square root of 5 squared, I have plus 5 minus square root of 5 squared, j hat. That will be 5 I hat. And that's also 5 here, right? So we have, oh, that's it. So 5 I hat then. Yeah, j hat is 0. Yeah, okay. So they say that this is a parabolic path. So that will be, look, So this is a plane curve because we have only ij, right? So that will be x. This will be y, right? So in other words, this is, we can express this is x over t. This is y over t, right? Okay. Now, when t equal to 0, we have approximately 2.24 j. So there will be 1, 2, 3. So 2.24, it's about here, approximately, right? Okay, then when t equal to 1, we have 1. 1i plus 2j. So it's over here. When t equal to 2, we have 4i plus j, right? So 1, 2, 3, 4i, then j, 1. Yeah. Okay, how about square root of 5? Square root of 5 is about the 2.24 approximately, right? And then we have 5i. So there will be 1, 2, 3, 4, 5i, right? So it's like that. So I'm gonna connect all the dots. Ooh, yeah. So it's like that, right? Looks like a parabola, right? Okay. So this is a vector valued function. So orientation toward to this direction, right? So how about like that, right? Yeah. Start here, go to this direction. Yeah. Normally we indicate it like that. Yeah. Okay. Now, we want to know about the velocity vector when time t equal to 1. So we had when time equal to 1, that vector value of the vector valued function equal to I plus 2j, right? So 1i 2j, yeah? So from here, we want to know what the velocity function, right? So what was the velocity function? So hold on 1 second. T equal to 1. So velocity function, we have this one. Copy. So when t equal to 1, so v over t, v over t, t equal to 1, equal to r prime over t equal to 1, 2t, t equal to 1, I had, and minus t equal to 1 over, there. Come on. Minus 1 over, and 5 minus t equal to 1 square, which is 1, and 1/2. J hat. Yeah. Okay. So 2i hat, 2i hat, correct. So 2i hat, and then we have 4 and 1/2. So negative 1/2, not. We have 1 over 4. So basically square root of 4, yeah? 1/2 means, right? So 1 over 2, right? So we will have 1 over 2 j hat. Yeah. Okay. So let's draw, sketch. So 2i. So 2i, right? And then negative. Oh, hold on 1 second. I'm not doing the original one. We are sketching the velocity, right? From t equal to 1. So when t equal to 1, we have I to j. So from here, we want to sketch 2i. So 2i. So 2 unit to the right from here. So 1, 2. 1, 2. And then negative. So what was it? This one, this is 2j, right? 1, 2j. So we have 1, 2, 1, 2, and then negative 1/2, just half, yeah? So you guys okay? So from here, I want to 1, 2, and then the negative 1/2, yeah? So that will be that. That is a velocity when t equal to 1, which is 2i minus 1/2 2j hat. Make sense? Okay, so let's talk about velocity vectors and acceleration vectors. Velocity and acceleration vectors. Okay, so we have a nice picture here. Think about we are driving, yeah? Okay, then if we have curve, sharp curve, then if this car driving straight, then this one get off the road, right? So we're trying to steer wheel to the left to get the road, right? Okay, so we're going to, this way is, we have a direction, so we call the velocity vectors, yeah? Okay, then we talk about the tangent vector before, right? So tangent vector, like think about the tangent line. So touch the graph, right? So just to touch the graph, but it's a vector. So it's going to the same direction with the particle, right? So we have acceleration because the car moving with the acceleration, right? So then going to this direction is we say that tangential acceleration, and then we indicate a sub t, yeah, the t from the tangent vector, right? And then we know normal vector is orthogonal to tangent vector, right? So we have acceleration and then normal acceleration, which is orthogonal to tangent vector, right? So we denote a sub n there. Okay, so we have bunch of theorem here. Theorem 3.7, the plane of acceleration vector. So just remember we have just the principal unit tangent vector and principal unit normal vector. Now we are using this formula to find out tangential and normal component of acceleration. So we have tangential acceleration. We are using this formula. We have normal acceleration. Then we are using this formula. Okay. So let's do problems. Do I have one? Okay. So Okay, this is the question particle moves in paths. And we have a vector function that. Then we want to find the tangential acceleration and normal acceleration. And then second part, we want to find those when t equal to 2. All right? Okay, so let's bring the formula here, everything. So let's make a little bit different coloring, right? Ooh. Okay. All right. First of all, the tangential acceleration. You know, t, huh? Okay. Then dot product of velocity vector with the acceleration vector over magnitude of velocity, right? Okay. Then let's find out what's the velocity first, then acceleration, right? Okay. Okay, so we have a velocity function, which is the r prime of t, right? So we have a 2ti plus 2j plus 6t minus 3k, right? Okay, now acceleration, which is the derivative of velocity, which is the same as second derivative of the vector function, right? So that will be 2i hat plus 0 and plus 6k hat, right? Okay, now dot product. So let's do this one. Okay, paste. Oh, I have to erase everything? No, hold on one second. Okay, let me just write that. Tangential acceleration, the dot product of velocity with acceleration and magnitude of the velocity, right? Ah, someone might confuse with just vector v, huh? Because we've been using that, right? So this is a velocity vector. All right, so that will be dot product gives us a scalar. So we don't carry the ijk vectors. Okay, so v. So that will be, how about 2t, 2, 6t minus 3, dot product with acceleration 2, 0, 6, all over magnitude of velocity, which is, oh, square root. Square root velocity. So 2t squared plus 2 squared plus 6t minus 3 squared, right? Okay, let's do it. That will be 2t times 2 plus 2 times 0 plus 6t minus 3 times 6. Yeah. All over square root 4t squared plus 4 plus 36t squared plus 12 times 3, 36 t plus 9, right? Please correct me if I make a mistake. Okay, so there will be 40, 0, then plus 36t minus 18 all over square root. Okay, combining, so 40t squared plus 36t plus 13. Okay, numerator 40t minus 18, right? Then we done. All right. Since we're doing the tangential acceleration, let's do when t equal to 2, right? So let's do that. When t equal to 2, so tangential acceleration, which is that, copy. So there will be 40 times 2, please calculate, minus 18 over square root 40 t squared 2 squared plus I was checking I'm recording and 36 t times 2 plus 13. Okay, so thank you. So we get 62 over square root of 101. Good job. Okay, now second one, we want to find the normal acceleration. Okay. We could use this one, right? So you can do that. We can do that easily, right? So cross product first, and then we make a magnitude, right? Also, we can do this one too. So I'm gonna try this one. You try this one, all right? Let me copy. For the normal acceleration, right? Okay. We had, did you know we have acceleration? We have, right? So we have this one. Copy. Okay. Then inside the square root, so a sub n equal to square root magnitude of a square. Okay. Then we have to have a square, right? But then there's a squared. Okay, let me show you first. So we have a squared. So there is a 2 squared plus a 6 squared and squared down. which is same as just inside, right? Minus, we have a tangential acceleration squared, right? Okay. So basically, we want to find when t equal to when t equal to 2, right? So with just the letters, variables, it's a lot of work. How about just using whatever we have earlier, right? So here, when t equal to 2, yeah. So basically, we're combining everything. So when t equal to 2, let's do that together. Okay, so there will be 62 over square root of 101 square down then. Okay, so there will be hold on 1 second. Maybe we just try. So we have 4, 36 is 40 minus, oh, I need to calculate, right? Can you calculate? Okay, so 62 squared, we get 3844 over 101. So inside the square root, we make a common denominator, right? So we get 101 times 101. So that will be 40, 40. Oh, nice number. 40, 40. 40, 40, 40, 40. 40, 40. 40, 40 minus 3844 over 101. That will be square root 196 over 101. So square root of 196, we get 14 over square root of 101. Yeah. Okay, so this time we do projectile motion. So we did this kind of problem in algebra, in trigonometry, and pre-calculus and calculus 1, right? So this is a calculus 3. So let's learn in calculus 3 ways, right? So we know what's a projectile motion. Looks like that, right? And we have to know the gravity, which is 32 feet per second squared. And if we using unit meters, then 9.8 meter per second square. So if you are taking physics or you took physics, normally we using meter per second square, right? Okay, then we have a force. So we denote force about the gravity, yeah? Then, so gravity from the, is pulling from the ground, right? That is the gravity means, right? So we get negative mg, the formula. So m is mass, g is gravity. Yeah, makes sense, right? Okay, then we call this is Newton's second law. If you took the not calculus, physics, or if we are taking physics, right? So Newton's second law. We have another force. Oh, let me write down the number 2 force. So we have m equal to mass, then acceleration. So where m is mass and a is acceleration, right? So we have a vector notation, so vector of object. Okay, now we have two different force. So we can just say that force equal to force, right? So force equal to force. Then we indicate that this force from this force from the gravity force, right? Okay, then this second force is m times the acceleration of a vector, right, of the object. And then the gravity force, we know negative mg, yeah? Okay, now we can divide by m both sides. Then we get a equal to acceleration equal to negative g, right? Oh, missing j. Yeah, okay. Then we know that what is the acceleration in terms of other vector. So we know that acceleration of t equal to the derivative of velocity, right? Okay. Now we want to know about the velocity. How? We take the integral of derivative of velocity. Then we get the velocity vector, right? Okay, we did the integral before, so you can refresh, yeah? All right, then what is v prime of t? That is the same as acceleration, right? So let me rewrite. So that will be acceleration. Then there will be acceleration, we denote negative gj, right? So that will be negative g j dt. Yeah, we want to integrate respect to t, then what do you get? So this is a number, right? So we will get negative gt j plus c, right? Okay, so that will be negative g t j hat plus c. Okay, let's denote this is a c sub 1. All right, now say let's find what's the c sub 1 in that case. Then let's say that initial velocity when t equal to 0. So we have a v of 0 equal to, say, v naught. Okay, now we have a v of t equal to negative gt j plus c sub 1, right? All right, then when t equal to 0, so v of 0 equal to negative g 0 g plus c sub 1 give us the name V naught, right? We said earlier, right? Okay, then we say that C sub 1 equal to V naught. Yeah. Okay, then going back again, we have a V of T equal to that, and then C sub 1. C sub 1, what is C sub 1? It's V sub 1. I'm sorry, V sub 0. Make sense? Okay, so let me down. Let me write down. Not let me down. Okay. Therefore, we have V of T equal to negative GT J hat plus C sub 1, which is V naught. Yeah. All right. Good job. All right. Next, we have V of T. V of T. Hold on one second. All right. So we have a V of T. Then how do we indicate V of T with the other vector function? We had R prime of T earlier, right? But let's just using S of S prime, I'm sorry, correct, S prime of T, right? So I'm not using R, I'm using S. We can use anything, any variable, right? So this is the S of S prime of T. Yeah, velocity same as the first derivative of the original function, right? Okay, now let me just rewriting negative GTJ plus V naught. Okay, same processing like this. Okay, how do we get the S? We want to integrate of S prime of T, right? Okay, so let's do that. So we can S prime of T integral, then we get S of T, right? All right. Then we want to integrate this one too. Negative GT J hat plus V naught and DT. Okay. Now we want to integrate what you get. So negative GT squared over 2 J hat plus V naught T, right? And plus C, right? Okay, let's say that this is a C sub 2. All right, same concept. This one, this one. So say initial velocity when t. So this is not velocity, this is a position vector function, right? So let me say that. Say initial position vector when t equal to 0, right? Okay, then S of 0 equal to S naught. Yeah. Oh, vector notation, huh? Okay. I do not have that, huh? So, okay. Then we have S of t equal to that, right? So I'm checking recording. Okay. Always worry. So S of t. Ooh, sorry. S of t equal to negative gt squared over 2 j hat plus v naught t plus c sub 2. Okay, when t equal to 0, so we have s of 0. Oh, different color. Okay. When t equal to 0, s of 0 equal to negative g 0 over 2 j hat plus v naught t is 0, right? Plus c sub 2. And then we say that when s of 0 equal to s naught, right? So s of 0 equal to s naught, right? Yeah. Then every term is 0. So c sub 2 equal to s naught, right? Same as earlier. Okay, then s of t. Yeah, we do this. C sub 2. What's the C sub 2? Oh, supposed to be C sub 2 equal to S now, right? C sub 2 equal to S now. Okay, S of T. Compute that. Then C sub 2 will be S naught. Yeah. Okay. Now, we have initial velocity and then projectile motion with the angle. We express as I hat as a cosine theta, and then j hat we express as a sine theta. Okay, so let me write down initial velocity for projectile, not the projection. Projectile motion with angle theta. Okay, so V naught equal to V naught cosine theta V naught equal to V naught cosine theta I hat and plus V naught cosine, I mean, sorry, sine theta, right? J hat. Okay, so be aware of that. This is a vector and this is number, right? And this is also number, V naught. Yeah, so then those are number. Oh, it's not. I'm sorry. You're crazy. Is it vector? Okay, let's move on. So we have when x not equal to 0, let me write down. Not when the particle throw from origin, then it's not equal to 0. Okay, then we have copy this. Then we have this is equal to 0, right? So S over T equal to negative GT squared over 2 J hat plus V naught T. Okay, then what was the V naught? So let's say using V naught here, right? So there will be negative GT squared over 2 J hat plus V naught will be that. Okay. And then we have a T there. Yeah. So we do distribute. So there will be negative GT squared over 2 J hat plus V naught T cosine theta I hat plus V naught T sine theta J hat, right? Okay, we can see that this is a J hat, this is J hat, right? So we can combine J hat with J hat, right? So that will be V naught T cosine theta I hat and plus, which one first? The sine first. So V naught T sine theta minus 1/2 GT square. And then we say that J has, so component wise, we arrange. So actually we create this formula here. This is the formula, all right? Okay, let me write down, highlight this one. So this is the formula for projectile motion. Okay, so let me bring the example so that this will be last example. Oh, it's long. Okay, motion of a cannonball. All right, so we have an example, motions of cannonball. So Cannonball is fired from cliff toward the water. It's aimed angle 30 degree above horizontal, and the initial speed cannonball is 600 feet second. So that will be the V naught, the initial velocity, right? The cliff is 100 feet above the water. We want to find the maximum height of a cannonball. Yeah. So what is the maximum height from the water or from the cannonball? Yeah. Okay. So I wrote down here. So what's the maximum in the case? So we learned from the calculus 1, right? So when velocity, the position vector is equal to 0, which is the velocity same as equal to 0, right? Yeah. Okay. Then how do you find? So we want to find the time t. Then we actually substitute into the position vector, right? That is the maximum height we can find. Make sense? All right, let's do it. So let me write down A part. Find the position vector prime equal to 0. Then find the t time. Then substitute t into the position vector. Okay, so let's do it. V naught, we had V naught equal to 600 feet. Let's bring the formula first. So we are using this formula, the position vector. Okay. Okay, so V naught, which is 600 T cosine 30 degree, right? Because they say so, 30 above horizontal, right? So from horizontal, 30, yeah. Okay, so 30, I had plus V naught 600 T sine 30 minus 1/2. What is the unit? Is it 9.8, 30, or 32? Okay, so they're using feet. If we have a feet, we are using 32 feet per second squared. Yeah. Okay. So G equal to 32 feet per second squared, right? So 32 and T squared, G hat. Okay, now let's simplify. So what's the cosine 30 degree? We did that so many times this semester, right? So there will be 600t square root of 3 over 2 I hat plus 600t sine 30 degree, which is 1/2, right? Minus simplify, which is 16. 16t squared j hat. Okay, now simplify more. 2 goes to 600, 300 times. That's it, right? What else? So we have a 300t. How about square root of 3, right? So square root of 3. Square root of 3. I have plus 300t minus 16t squared j hat, right? Okay, now, can you please derivative of that? Oh, t missing, which is velocity of t. All right, so we get 300 square root of 3 I had plus 300 minus 32t j hat, right? Okay, so let's make equal to 0. So there will be 300 square root of 3 I hat plus 300 minus 32t. I could not see the t earlier. J, right? Okay. Look, we want to know about the only vertical distance because maximum heights, right? So calculus 3, we have a direction. So whether this direction or that direction, right? So we're using only the J component. J component. Vertical distance, right? Maximum height. Okay, so we have 0 equal to 300 minus the 32t and solve for t. Then t will be 300 over 32, yeah? Can you please calculate? 9.375 second. Very good. Okay, now we have a t, then we substitute into the position vector to solve the maximum height, right? So S of t, position, copy. So we have that. S of t, then, so we substitute S of 9.375 equal to 300 square root of 3, 9.370575 I had plus 300 9.375. Hey, too long. Minus 16. No space. square, and then j hat, right? So I want to make a little bit smaller. Okay, so 9.375 squared, right? Okay, can you please calculate j hat? Okay, so I component, we have a 4,871 I had plus j hat. Yeah, actually we need only the j component, right? So 1406.25 j hat. Yeah. So we need only j component. So 1406.25 feet from the above cannon, right? Let me just say what. Above cannon, or 1406.25 plus 100 feet. That would be 1506.25 feet from above sea level. Yeah. Okay. Let's do second part. So second part. Okay, second one we have how long will it take for the cannonball to splash into the sea, right? So we want to find time t, right? Okay, so let's do it. Second part. Sorry for t. All right, so we have the position vector S of t here. Okay, let us think about that. What kind of component we have to use, right? So the cannonball splash into the sea. So this is the vertical distance, right? So vertical distance we were using the J component, right? Earlier. So the vertical distance. So J component, right? Okay. Now, so we have 300t minus 16t squared. Then look. So the height is 100 feet, right? From here to here. Then splash into the water, we can set it up negative 100. So it's a negative 100. Okay, now solve for t. How? Yeah, quadratic formula, right? So let's move everything one side. So negative 16t squared plus 300t plus 100 equal to 0. Big number, so divide by negative 4. every term. So we get 4t squared 4t squared minus 75t minus 25 equal to 0. So quadratic formula, t equal to negative b plus minus b squared minus 4ac all over 2a. So negative b, so positive 75 plus minus b squared, 75 squared minus 4 times 8 times negative c all over 2 times a, right? Please calculate everything. Okay, so we have two answers. One is negative 0.33 or 19.1, right? We cannot have time as a negative, so we do reject this one. And we take this one, solution. Yeah. Time. All right. It's second, right? Okay, let's do the third one. The last one. Oh. Okay, so the third one, how far out to sea will the cannonball hit the water, right? So how far? So in that case, it's a vertical, I'm sorry, horizontal distance. So it's very similar with the first one, right? But then the first one, we were using the J component for the vertical distance. This is a horizontal distance. We are using the I component, right? Okay. Then let's see. We have a position vector. Okay. See. Horizontal distance. So use I had component, right? All right. So we have this one. Then the time. So we had the time 19.21 about the splash into the water, right? So let's see using that. The position vector that and t equal to 19.1 from second part. Okay, then we want to know about the only the I component. So as of 19.1 when times, right? What's the vertical? I'm sorry, I keep the saying the word vertical, right? Horizontal, right? So equal to 300 square root of 3 t, which is 19.1. So what do you get? So can you please calculate? So I got 9,924 feet. So we got actually rounding 9.0776, right? So if t equal to 9.0776, we can get as a textbook fit. All right. Okay. Any question? If you have any question, please let me know. Thank you for watching. I will see you in the next section. Thank you. Bye-bye.